Hello and welcome to part 3 of the chapter 6 Triangles. In the last part, we saw one theorem, that is basic proportionality theorem, also known as Thales theorem or popularly known as BPT. Today we are going to see the next theorem, and the next theorem is areas of similar triangles. Let's see the statement. The ratio of the areas of two similar triangles is equal to the square of the ratios of their corresponding sides. What does it mean? I'll explain you with the figure. Here is the figure. There are two triangles, ABC and triangle PQR, which are similar. Given triangle ABC is similar to triangle PQR, and AM is drawn perpendicular to BC and PN is drawn perpendicular to QR. What is asked to prove is, see the statement, the ratio of the areas of two similar triangles, that is area triangle ABC upon area triangle PQR, is equal to square of the ratios of their corresponding sides, that is AB square upon PQ square, because AB and PQ are corresponding sides. BC square upon QR square is equal to AC square upon PR square. Due to some technical problem, I have put square signs both numerator and denominator. Actually, you can write AB upon PQ whole square, BC upon QR whole square, and AC upon PR whole square. I'll come to that little later. Now, this is what we have to prove. Now see, what is asked to prove is ratio of areas of two triangles. So we are going directly to the ratios of areas of two triangles. And we use the formula half base into height. If you look at triangle ABC, half BC into AM, and triangle PQR, it is half QR into PN. So from statement 1 we get half gets cancelled, and you get BC upon QR, area triangle ABC upon area triangle PQR, is equal to BC upon QR into AM upon PN. I have separated the two ratios. What we want, if you go to C to prove, we want BC upon QR whole square. That means if we replace AM upon PN by BC upon QR, we'll get the square. That means we have to prove the ratio of AM upon PN, both are the altitudes, AM upon PN is equal to BC upon QR. BC and QR are the corresponding sides. So now we will go to this is the first part. Now we will go to the two triangles which includes AM and PN. AM is there in triangle AMB and AMC. Same way, PN is there in triangle PNQ and PNR. We will select any one. We will select AMB and PNQ, and we'll try to prove them similar. First of all, there is each is a right angle is there. Triangle AMB is equal to triangle PNQ. Second is, we are given already triangle ABC and triangle PQR are similar. And in the beginning we have seen when the two triangles are similar, the corresponding angles are equal. And B and Q are the corresponding angles of triangle ABC and triangle PQR. Therefore, they are equal, corresponding angles of similar triangles. So with the help of these two, that is statement 3 and statement 4, what we can prove is triangle AMB is similar to triangle PNQ, AA similarity criterion. We'll write the corresponding sides. AM upon Pn, say the correspondence, AM upon Pn is equal to MB upon NQ is equal to AB upon PQ. Now here if we see, we already got that ratio AM and Pn, AM upon Pn. We want to show this ratio AM upon Pn is equal to BC upon QR. That is not there. That ratio is not here in statement 6. Therefore, we are going to the original triangles which are already given similar. Statement 7, triangle ABC is similar triangle PQR, and we get the corresponding sides of similar triangles equal, that is AB upon PQ, BC upon QR is equal to AC upon PR. The most important part now. If you look at statement 6 and statement 8, there are no 6 ratios but 5 ratios, because you can see AB upon PQ is there in 6 as well as in statement 8. Since this ratio is common, all the remaining 5 ratios are equal, because in statement 6 there is AB upon PQ, in statement 8 also there is AB upon PQ. Therefore, all the 5, that is AM upon Pn is equal to MB upon NQ is equal to AB upon PQ is equal to BC upon QR is equal to AC upon PR. All are equal. But we don't want all equal. What we want is, we want to prove that is AM upon Pn, you can say that in statement 6, is equal to BC upon QR, which is there in statement 8. Now, once you prove these two equal, we can go to statement 2, where there is AM upon Pn, and you can replace there by BC upon QR. I have written the reason here from statement 2 and statement 9. You get BC upon QR into BC upon QR, and from statement 10 we get area triangle ABC upon area triangle PQR is BC square upon QR square. But we are asked to prove all the 3 ratios. If you go back to statement 8, you will, what BC upon QR is equal to AB upon PQ and also equal to AC upon PR. That means what is true for BC upon QR is also true for AB upon PQ and AC upon PR. So from statement 8 and from statement 11, we get the final result. That is area triangle ABC upon area triangle PQR is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. This statement, number of statement, there are 12, little lengthy theorem. Don't try to learn by heart. Once again, I will insist, remember the concept. I'm going to explain the entire theorem again, and what are the concepts you have to remember. Let's go to the entire theorem once again. You can see here the entire theorem, but I will not explain here. Here also there is an entire theorem. I'll come here. See what is given. The ratio of the areas of two similar triangles is equal to square of the ratios of their corresponding sides. Given triangle ABC is similar to triangle PQR, AM is perpendicular to BC, and PN is perpendicular to QR. What is asked to prove? Area triangle ABC upon area triangle PQR is equal to. This is what I was talking to you. Because of some technical problem, square was put at numerator and at denominator. Actually, you can write AB upon PQ whole square is equal to BC upon QR whole square is equal to AC upon PR whole square. As I told you earlier, left hand side of what is asked to prove the ratio of the areas of two triangles. Let's start with that. Area triangle ABC upon area triangle PQR. We will go to the definition of area of triangles. Half base into height, half BC into AM upon half QR into PN. Half gets cancelled. And now you can see here BC upon QR into AM upon PN. Area triangle ABC upon area triangle PQR is equal to BC upon QR into AM upon PN. And what we want is here, that is BC upon QR whole square. So if you replace AM upon PN by BC upon QR, you will get BC upon QR square. This is the first part you should remember, the first concept. Second concept is you have to select two triangles having AM and PN as sides. So we got the two triangles here, AMB and PNQ. There is each is a right angle because AM and PN are the altitudes. B and Q are the corresponding angles of similar triangles, that is the original triangles. Therefore, the two triangles are similar by AA criterion, and we get the corresponding sides of similar triangles here. We are getting the required ratio. AM upon PN is equal to MB upon NQ is equal to AB upon PQ. But we want AM upon PN is equal to BC upon QR. For that, this is the second concept. The third concept is go to the original triangles. When you go to the original triangles, they are already similar. So AB upon PQ is equal to BC upon QR is equal to AC upon PR. Our ratio is here BC upon QR. And you can see in sixth statement, that is AB upon PQ. And in the eighth statement also there is AB upon PQ. That means total 5 ratios which are there, because one ratio is the common, all are equal. Therefore, in the previous where I proved, I did not say AB upon PQ. I wrote only BC upon QR is equal to AM upon PN, because we want only those two ratios equal. Doesn't matter even if you write which is common to both. That is statement 6 and statement 8. That is AB upon PQ is equal to BC upon QR is equal to AM upon PN. Now, we are ready to prove, because we got AM upon PN is equal to BC upon QR. Let's go back and see what is there. Here, statement 2. BC upon QR into AM upon PN. I told you in the beginning, we want to replace that AM upon PN by BC upon QR so that we get BC upon QR square. And here we have already proved in statement 9, BC upon QR is equal to AM upon PN. So in statement 2, in place of AM upon PN, now we can write BC upon QR, which makes area triangle ABC upon area triangle PQR is equal to BC upon QR whole square. But we want to prove this for all the 3 corresponding sides. Go back to statement 8. BC upon QR is equal to AB upon PQ is equal to AC upon PR. That means whatever is true for BC upon QR is also true for AB upon PQ and AC upon PR. That is from statement 8 and statement 11 we get the final result. You can write this in a notebook from this part. This is a handwritten slide. So this theorem is not very difficult if you remember those concepts which I told you. Just remember the steps. One very peculiar thing is this theorem is never asked in the board paper. Doesn't mean that this will not come this year in the board paper. There is every possibility that this theorem can be asked in the board paper this year because this is included in the syllabus and it is not very difficult. Students, you are aware that from this year, Goa board has introduced level 1 and level 2 in mathematics. Now these two theorems which we have covered first two, that is BPT and areas of similar triangles, this both the proofs, not the theorems, only the proof is deleted in level 2. They will have only the last two, third and the fourth theorem, while level 1 will have all the four theorems with proof. Hope you have gone through the circular number 41, which clearly says those who want to pursue further education in science or with mathematics, whether it is arts or commerce with mathematics, they should opt for level 1. Only those students who find very difficult maths, very difficult, they can opt for level 2. Otherwise, there is no need. Level 1 is not a higher level. It is the same level which was there till last year. For any further clarification, any further doubts, you can contact your concerned class teachers or your concerned maths teachers. That's all for today. See you again with theorem number 3 next time. Bye.